atmosphere is actually streaming all the way out. It bathes all of our planets on the way to the very edge of our solar system. In fact, it shapes our very place in space.
NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
Breaking news. We may have just found potential evidence of intelligent life beyond Earth.
This is a huge discovery, and we think that it's a huge discovery. And that's the most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful.
NASA has found a super-Earth that could have conditions to support life. The new exoplanet is 137 light-years away, or approximately 800 trillion miles. Cosmologists say the planet is around 1.5 times the size of Earth and orbits a small, rosy star that is cooler than our Sun. NASA's James Webb Space Telescope has scarcely begun its mission, and already, the universe appears more mysterious and beautiful than humanity's wildest dreams. This is incredibly thrilling. While we haven't found an exact twin for Earth, this planet isn't far off. Out of the latest batch of 500 new potential planets, this one is about 50% larger than Earth. A tremendous revelation. Scientists believe this discovery could revolutionize our understanding of the universe. The James Webb Space Telescope, JWST, is so powerful that, with enough time, it could likely observe every galaxy ever formed. Its advanced technology allows us to uncover cosmic secrets, some of which challenge our current understanding of how the universe began. The discovery of PROXIMA b, one of JWST's most exciting achievements, was providing the clearest image of PROXIMA b, sparking excitement and curiosity. This remarkable image shows one of the closest Earth-like planets in vivid detail. But what secrets does this distant world hold? Could there be life there? What might this new clarity reveal about space mysteries that remain unsolved? By diving deeper into these discoveries, we expand our understanding of the universe. Observing the formation of galaxies requires looking back across billions of years. The James Webb Space Telescope enhances our ability to observe the universe at unprecedented distances, using infrared technology to capture visuals unlike anything we've seen before. Just when we thought we understood the cosmos, new findings upend our assumptions. For example, some galaxies are more massive than previously estimated. A major milestone was JWST's capture of the clearest image of PROXIMA b, marking a significant breakthrough in space exploration. Earlier observations in 2013 hinted at PROXIMA b's presence through subtle gravitational effects on its star. Subsequent research revealed PROXIMA b's harsh conditions. Characteristics of PROXIMA b. PROXIMA b's dark side, always turned away from its star, is extremely cold, possibly freezing any water. Orbiting Proxima Centauri, the closest star system to the Sun, PROXIMA b offers a glimpse into the Alpha Centauri system as it appeared years ago. Despite being one of the most Earth-like exoplanets discovered, PROXIMA b is vastly different from our planet. For instance, a year on PROXIMA b lasts just 11.2 Earth days. The planet is 30% larger than Earth. It orbits its host star, Proxima Centauri, at a mere 7.3 million kilometers, less than 5% of the Earth-Sun distance. Proxima Centauri, a red dwarf star, is much smaller, cooler, and dimmer than the Sun. From PROXIMA b, Proxima Centauri would appear as an enormous red disk in the sky, larger than the Sun from Earth but dimmer. While the star's location in the habitable zone raises the possibility of liquid water, this doesn't guarantee Earth-like conditions. PROXIMA b is likely tidally locked, meaning one side remains perpetually in daylight while the other endures eternal night. This division creates extreme conditions. The sunlit side could be scorching, evaporating surface water, while the dark side could be so cold that any atmospheric moisture would freeze. Challenges for life. Proxima Centauri's intense solar flares and radiation make survival on Proxima b extremely challenging. Research suggests Proxima b experiences over 2,000 times the solar wind radiation Earth receives. In April 2021, Proxima Centauri unleashed the most powerful solar flare ever recorded, 100 times stronger than the most intense flare observed from our Sun. Such conditions present significant barriers to life as we know it. Even so, the discovery of Proxima b and its proximity to Earth fuels scientific curiosity. In late 2020, a mysterious signal was detected from the Alpha Centauri system, further heightening interest in exploring the region. The future of space exploration. The dream of interstellar travel is inching closer to reality. One promising initiative is the Breakthrough Starshot project, which aims to drastically reduce the travel time to Proxima Centauri. Instead of taking centuries, this technology could allow us to reach the nearest star system within a few decades. While challenges abound, the combination of advanced telescopes like JWST and pioneering exploration programs underscores humanity's determination to unravel the universe's mysteries. Each discovery brings us one step closer to understanding our place in the cosmos and perhaps, one day, finding life beyond Earth. Distant. It denotes a colossal step in the right direction in our capacity to investigate the universe. To accomplish this ambitious objective, researchers are delving into exciting ideas like driving spacecraft at nearly the speed of light. This would mean harnessing revolutionary new technology to push the boundaries of what we thought was possible. One idea involves using the power of light itself to propel spacecraft by utilizing powerful lasers to send small, lightweight probes plunging through space at incredible speeds. This could make interstellar travel more practical. The technology being explored has the potential to take us far beyond what conventional rocket engines can achieve. However, even with these advanced ideas, interstellar travel is still extremely challenging. If we were to rely on today's technology, a journey to Proxima Centauri would take around 6,000 years, an unimaginably long time for any human mission. As space exploration progresses, new ventures and advancements are continually being developed. One of the most exciting of these is the Starshot initiative, which is specifically focused on overcoming the vast distances between stars. Starshot is investigating the potential of using extremely powerful lasers to propel small, high-speed spacecraft toward Alpha Centauri, the star system that contains Proxima Centauri. These spacecraft, though tiny, could gather critical data about distant planets, helping us better understand the possibilities for life beyond our solar system. This approach could significantly accelerate space travel. By directing intense laser beams at spacecraft equipped with reflective sails, these probes could rapidly accelerate to near-light speeds, potentially reaching Alpha Centauri in just 20 to 30 years. Although these missions would be unmanned, they would dramatically advance our understanding of the universe. Adaptive optics play a crucial role in these projects by correcting distortions caused by Earth's atmosphere, which affect both space-based light and propulsion lasers. These advancements ensure that lasers remain focused and effective during space travel. Despite the challenges, breakthroughs in laser propulsion, adaptive optics, and spacecraft design are promising. Interstellar travel is evolving from a distant dream into a feasible endeavor, potentially allowing us to reach Proxima Centauri much sooner than expected. What once seemed like science fiction is now becoming attainable, potentially revolutionizing our exploration of the stars. Even with all these advancements, many technical, logistical, and financial obstacles remain. However, the determination to press forward, driven by humanity's desire to explore the unknown, demonstrates that these challenges will not stop us from dreaming of reaching the stars. The question now is not if we will one day travel to Proxima Centauri, but when. The ambitious plan is for the spacecraft to reach Proxima Centauri in just 22 years, powered by lasers generating an astounding 100 gigawatts of energy, about equivalent to the total amount of electricity used by the entire United States at any given time. This impressive energy output is necessary to accelerate the spacecraft to a significant fraction of the speed of light, allowing it to cover the vast distance between Earth and Alpha Centauri in just over 2 decades. However, despite the promise of this plan, many challenges remain. Navigating the vast emptiness of interstellar space might sound straightforward, But in reality, the spacecraft would need to avoid interstellar debris, tiny particles that could severely damage it while traveling at such high speeds. Even if the spacecraft successfully avoids these obstacles and reaches Alpha Centauri, there remains the issue of communicating back with Earth. The distance between our planet and Alpha Centauri is so immense that any signal sent from the spacecraft would take 4 years to reach Earth. This means that even after the probe arrives, it will take another 4 years before we know whether it succeeded in its mission or what data it was able to collect. Managing this delay in communication adds yet another layer of complexity to an already challenging mission. Once the initial launch system is successfully developed and tested, it could pave the way for a future where space missions become significantly more cost-effective. The high costs and challenges associated with interstellar travel have long been a limiting factor, but breakthroughs like laser propulsion systems could make launching additional spacecraft to explore distant stars much more feasible. One of the most exciting possibilities is that these advanced probes wouldn't have to be limited to a single destination. While Alpha Centauri, as the closest star system, is the most obvious first target, other systems such as Proxima Centauri and even farther ones could soon be within reach. Each new mission could provide invaluable insights into the planets that orbit these distant stars, especially exoplanets, planets located outside our solar system. By sending multiple probes, we could gather a broader range of data, giving us a clearer picture of what these exoplanets are like. The more we explore, the more likely we are to discover new worlds that may be capable of supporting life, which remains one of the most profound questions in science today. Exploring exoplanets is a critical part of these missions because of what they represent. The possibility of finding life beyond Earth. Exoplanets have captured the imagination of scientists and the public alike, as they offer us the chance to answer one of humanity's oldest questions. Are we alone in the universe? Many of these exoplanets have been found within the habitable zone of their parent stars. This region is sometimes called the Goldilocks zone because it is not too hot and not too cold but just the right temperature for liquid water to exist. Since water is a fundamental requirement for life as we know it, the presence of water on an exoplanet raises the likelihood that life could potentially exist there. The study of exoplanets has come a long way since the first confirmed discovery of planets outside our solar system in 1992. These early discoveries were of planets orbiting neutron stars, a vastly different environment from our own. But as technology has improved, scientists have identified thousands of exoplanets, and many of these planets are not only similar in size to Earth but also exist in their stars' habitable zones. These Earth-like exoplanets are particularly exciting because they may have conditions that could support life, either as microorganisms or perhaps even more complex life forms. Each new discovery brings us closer to answering whether life exists elsewhere in the universe. Studying distant exoplanets can greatly enhance our understanding of planetary formation and diversity. By examining how these planets form and evolve, we learn more about the origins of our own solar system. Comparing the atmospheres of exoplanets with those of Earth, Venus, or Mars helps us understand how planetary environments develop. This understanding can also predict Earth's future climate and the factors that influence a planet's ability to support life. Additionally, research on exoplanets addresses fundamental questions. What conditions allow for life? How common are Earth-like planets? Could some planets be even more hospitable than Earth? As we send more probes and analyze more data, we'll better understand our place in the universe. In the future, with an established laser propulsion system, we could envision a fleet of small, fast probes exploring various star systems. Each would be tasked with gathering data, analyzing the atmospheres of distant exoplanets, and searching for signs of water or other conditions essential for life. The probes could send back information about the chemical composition of these planets, the temperatures on their surfaces, and whether they have moons or magnetic fields, all critical factors in determining whether life could survive there. And it's not just about finding life. Exploring exoplanets also allows us to better understand the diversity of planetary systems. Some exoplanets may have conditions that are incredibly different from anything we've seen before. Gas giants with massive storms, frozen worlds covered in ice, or planets with extreme volcanic activity. These discoveries expands our knowledge of the universe and helps us understand how planets function fundamentally. Sending more probes to distant exoplanets helps us solve cosmic mysteries faster. As we explore and discover other planets, particularly those in habitable zones like the Goldilocks zone, our understanding of the universe and the potential for life grows. Advances like laser propulsion now make these missions more achievable, suggesting that answers to some of our greatest cosmic questions may be within reach. Since their discovery in the early 1990s, exoplanets have dramatically reshaped our view of the universe. Once thought to be speculative, we now know these planets are widespread, with many resembling Earth and potentially capable of supporting life. This realization has spurred intense interest in these distant worlds, especially those with conditions conducive to liquid water, a crucial component for life. But even beyond the search for life, the study of exoplanets provides valuable insights into the formation and evolution of planetary systems. By studying these distant worlds, scientists can learn more about how planets form, how they interact with their stars, and how their atmospheres develop. This knowledge, in turn, helps us better understand our own solar system and the history of planets like Earth. Moreover, the discovery of so many Earth-like exoplanets raises questions about the uniqueness of our planet. Are we truly alone in the universe, or could there be other planets that support intelligent life? Missions like the one aimed at Alpha Centauri are bringing us closer to finding the answer.